Hi everyone. In this video, we are going to discuss about transformation of quadratic equations. Well, it's nothing but creating a new quadratic equation from a given quadratic equation based on certain conditions, right? So let's take an example first and see how that works. So suppose we have been given a quadratic equation which looks like ax squared plus bx plus c equals 0, and the two roots of this quadratic equation are alpha and beta. So from this information, we can easily say that each of the roots will satisfy the quadratic equation. That means if we use the value of alpha in place of x, then it will look like this. We can say, okay, a alpha square plus b alpha plus c will be equal to 0, because alpha is a root of the quadratic equation, it must satisfy the quadratic equation. So this is one very important equation that we now created. Let's say this is equation number 1, let's say. And then also beta will satisfy the equation. So if we use the value of beta in place of x, then we will have a beta square plus b beta and plus c is equal to 0. So from here we get another equation, let's say equation number 2. So now just based on the given information, we have been able to create two equations here, right? Now suppose we are being asked to create an quadratic equation whose root will be, let's say suppose alpha plus k. So now we are being asked to create a quadratic equation whose root would be, let's say suppose alpha plus k, that will be one root, and then beta plus k. Now we are being asked to create a quadratic equation whose roots will be alpha plus k and beta plus k. Now let's see how to do that. For the new quadratic equation, we can say that, hey, for that equation, the value of the root will be alpha plus k. That means we can say that for the new quadratic equation that we are going to build now, for that new quadratic equation, x will be equal to alpha plus k, and also if we say x sub 1 will be equal to alpha plus k, we can say then x sub 2, the other root, will be beta plus k. Now let's forget about the beta, because both alpha and beta they going with the same style, because for the first root it is alpha plus k, for the second root is beta plus k. So we can probably just focus on this one set of information, and then we can create the new quadratic equation, right? So from here what I'm going to do, I'm going to say, okay, let's forget about x sub 1 or x sub 2, let's simply call it x. So now I'm going to say, okay, if we simply call it x as a root of the new quadratic equation, so x is going to be alpha plus k. From here we are going to get alpha is equal to x minus k. Think about it. Alpha, if we keep it on the right hand side, bring k to the left hand side, that becomes x minus k. So alpha is equal to x minus k. Now we are going to use this value of alpha in an equation where we have alpha. So now let's take a look up here, that we have two equations that we created based on the given value. Here is one equation which was equation number 1, and then another equation which is equation number 2. So we can clearly see we have an equation where we have alpha present in that equation. So now what I'm going to do, I'm going to take that equation and replace the value of alpha with x minus k, and that will give us our new quadratic equation. So far we have seen that based on the given requirement that, hey, the roots of the new quadratic equation must be alpha plus k and beta plus k. So we can simply use just the alpha plus k and then figure out, okay, what is the value of the alpha now? Well, for the new equation, the value of the alpha will be x minus k, and then we are going to now use that in an equation that we already have in our hand, and we are going to put the value of alpha there to create the new equation. So now I'm going to write it down here. So our information that we already have is like this: a alpha square plus b alpha plus c is equal to 0, and here I'm going to use this value of alpha. So from here we can say, okay, if we replace the value of alpha with x minus k, so this will become a times x minus k plus, a times x minus k whole square, this is alpha square, plus b times x minus k, and then plus c is equal to 0. And from here we can say, okay, so this will be, now let's do the whole square here. So it will be a times, now it would be x squared minus 2xk plus k squared, plus then again we have b times x minus k plus c is equal to 0. So from here, if we remove the parenthesis, this becomes ax squared minus 2 times akx, we can write it like that, plus ak squared, plus here we have b times x minus b times k plus c is equal to 0. Now let's write down all the x squared terms first. So we have only one x squared term, which is ax squared, and then how many x terms we have? Well, we have this one and then this one. So there are two x terms that I'm going to write next. So that will be plus x times, we can say b minus 2 ak, b minus 2 times ak times x. I'm just writing it in the coefficient form, so I'm kind of arranging them like this. So it will be positive b and negative 2 ak, positive b and negative 2 ak, that's what I have, and those are the two x terms. And then now we are left with only the constant terms, which are like ak squared minus bk plus c is equal to 0. And if we simply enclose that with a parenthesis, now you see this is also looking like a quadratic equation where we have ax squared plus something times x plus something that is equal to 0. So this is our new quadratic equation. So let me highlight this. So here, to create the new equation, what I did, I simply assume that the root of the new equation will be alpha plus k, and from there I convert that into a value of alpha. We say, okay, if x is equal to alpha plus k for the new equation, then from there alpha will be x minus k, and then I use that in one of the existing equations, and then we just simplify and we come to the final point where we have a new quadratic equation, right? So this is our new quadratic equation. Now if you had tried with the beta, you will get the similar, exactly similar looking quadratic equation. There will be no difference. Absolutely, there will be no difference. You can even try yourself. You can say, okay, if x is going to be beta plus k, from there you can say, okay, then beta will be x minus k, and then you use that in the second equation here, which is this one. So instead of using the value of beta, you cannot use the value of beta in the first equation because your equation with beta is the second one. So here, if you say like, if you do like this, let me quickly show you. So suppose if you are thinking that, hey, instead of taking alpha plus k, could we have done it with beta plus k? I would say yes, sure, we could have done that. So for the new equation, root would have been beta plus k, and from here again you see we can say, okay, from here again beta is equal to x minus k, and you are going to use this value of beta, you're going to use this value of beta in the second equation that has a beta square plus b beta plus c equals 0. You're going to put that value of beta in that second equation. Then also you will get the exact same new quadratic equation, which is highlighted here in the red box. So this is our new quadratic equation. And suppose if you are said that, hey, can you create a new quadratic equation where the roots will be say 1 by alpha and 1 by beta? Okay, let's try that. Now suppose we are taking another example where we have been told that the new roots will be 1 by alpha and 1 by beta. Okay, no problem. So for the new equation, we can say, okay, the first root we can say x sub 1 is equal to 1 by alpha, and then the second root will be x sub 2, which is equal to 1 by beta. Now let's simply go with the alpha. We'll simply go with this, and just with this we should be able to create the new quadratic equation. So if we go with this, then we can say, okay, no problem. We are now going to call it x instead of x sub 1 or x sub 2. Now we're just going to take a generic root. We'll say, okay, so here again x is equal to 1 by alpha, and from here we can say, okay, then alpha is equal to 1 by x. And now we are going to use this value of alpha. We are going to use this value of alpha in the first equation because we already have an equation in our hand that has alpha. There, right? So, and that equation is right here. That's the equation number 1 at the top. So that's an equation that we have, and we are going to put that value of alpha in that equation to create the new quadratic equation. So our existing equation here that we have is a alpha squared plus b alpha plus c equals 0. So now I'm going to use that same equation down below. So our original equation was a alpha squared plus b alpha plus c is equal to 0. Now I'm going to use this value of alpha right here, this value of alpha, which is 1 by x. So I'm going to use that value in place of alpha, right? So from here we can say, okay, this means that I can use, in place of alpha, I'm going to write 1 by x, and that is, we have alpha squared, so 1 by x whole squared, plus b times again 1 by x, that's the value of alpha. So b alpha becomes this plus c is equal to 0. From here if you simplify, it will be a times 1 by x squared. So it will essentially be a divided by x squared plus b divided by x plus c equals 0. From here we can say, okay, if we multiply both sides by x squared, then what will happen? Each of the terms will be multiplied by x squared. So this term will become a, then the second term will become bx because we are multiplying by x squared. So the x in the denominator will cancel one of the x, then we will be left with another x, and then it will be c times x squared, and then 0 times x squared will be 0. So from here if we rewrite this, we can say cx squared plus bx plus a is equal to 0, and this is also a quadratic equation, and actually this is the new quadratic equation that we were supposed to create. And here again you see that no matter what is the coefficient, we have an x squared term, also we have an x term, and also we have a constant term. So this looks perfectly okay for a quadratic equation, and this is the new quadratic equation. So anytime you have to create a new quadratic equation based on whatever condition is given to you, all you have to do is you have to first come up with your own original equations using the given roots that I did right here. So you want to do that first. Even just doing one of them will be fine too. You just use alpha and then come up with this equation number 1. That is the first thing you want to do. Then the second thing you want to do is you want to assume that for the new quadratic equation, x will be equal to whatever is the given root or whatever is the condition or criteria you have been given. Say for example, if somebody says, hey, create a new quadratic equation whose roots would be k times alpha, for example, and k times beta, right? So k times alpha, if this is what is the condition we have been given and we have to create the new quadratic equation, then you can say, okay, for the new quadratic equation, one of the values of x will be k times alpha. Then what is alpha? Well, alpha is equal to x by k, and then we are going to use this value of alpha in our equation number 1, and that will give us the new quadratic equation. Well, replacing the value of alpha, then you have to simplify a little bit. Finally, you have to bring it to a shape that would look like a quadratic equation. I hope the steps made sense. Thank you for watching. See you in the next video.